This is Unit 5, Part 4, and we're going to be solving systems of 3 equations. So it would be 3 equations, 3 variables. And our objective is to solve systems of 3 linear equations algebraically and use elimination to identify systems with no solutions or infinitely many solutions. When we get to this part, it works the same as with 2 equations and 2 variables. If you get down to where you have no variables at all and you have like a 1 equals a 1, something that's true, then it's going to be infinitely many solutions. But if you get down with no variables and there's going to be something like 0 equals 7, which is not true, then it's going to be no solution. So that's going to be the same as in Part 3. Let's look at the steps for solving with 3 equations. Step 1, we're going to take 2 equations and use elimination to get an equation with 2 variables. So they're going to start off with 3 variables. We're going to take 2 of the equations and eliminate one of the 3, and we'll have 1 equation with 2 variables. And then we're going to take the third equation and one of the 2 original equations and use elimination to get rid of the same variable that we eliminated in the first 2 equations. And what you're left with is 2 equations with the same 2 variables. You're going to take both equations with 2 variables and use eliminations to solve that system, just like we did in Section 3 or Part 3. You're going to substitute into the 2 variables to find the final variable. So we're really just doing elimination. We're just doing it one more time or a couple more times because we have 3 different variables. So let's look at example 1. Sometimes these things are set up easier so you eliminate a lot more at once. And in elimination, we want to look at variables that we can, if we add the equations together, they're going to have opposite signs and the same number in front so that we can just eliminate that variable without doing any multiplication. So let's look at the easiest way to organize these things is probably to just label them. And so if we label, and this is going to be hard to write in, but if we label the first equation as equation 1, the second equation as equation 2, and we got equation 3, 1, 2, and 3 for the equations going down. That way we can talk about the equations that we're using without having to describe the whole equation. We can say, hey, equation 1. And if I look at equation 1 and equation 3, I see I have a negative x right here and a positive x. So if I added these 2 together, I would eliminate an x. You should also notice that you're going to eliminate a y too, which is going to make things a little easier for us in this problem. It won't always work like that. So let's take 1 and 3 and we're going to add them together. And I'll put it in parentheses so we don't get confused on signs. So we're going to take negative x minus 5y equals 5, or minus 5z, sorry, equals 2. And we're going to add to it x plus 5y minus z equals negative 20. When I do this adding, I see my x's get eliminated, and I'll do this in red so you can kind of see everything. And my y's get eliminated when I add the negative 5 and the plus 5. And I would get negative 6z equals negative 18. Well, that's going to get our answer for z if we solve for z in this equation. Divide by negative 6, and we get z equals 3. So if we get z equals 3, we can take the z and now substitute 3 in for it if we want to, or we can look at taking the second equation, the equation that we didn't use, this one right here, and using that with one of the first 2 and eliminating what we can eliminate out of there. So if we look at equation 2, we can eliminate a y if we add it to equation 3. So we're going to take 2 and 3 and we're going to add them together. And so we're going to get 4x minus 5y plus 4z equals 19. and we're going to add to that x plus 5y minus z equals negative 20. When we add them up, we get a 5x. The negative 5y plus 5y cancel out, and we're going to get a plus 3z, because 4z minus z is a 3z. We got 19 and a minus 20. That's going to equal negative 1. But we also know that z equals 3 from this right here. So I can plug in and find x. I can plug in my 3 for z, and that would leave me with just one variable left. So I'd get 5x plus 9 equals negative 1. Subtract 9 from each side. 5x equals negative 10, sorry, and then you divide by 5, and you get x equal to negative 2. Let's see, I'm going to have to give myself a little more room. There we go. You get x equal to negative 2. So now we have x, we have z. All we need to do is take one of my first 3 original equations, plug in the x and z that we know, and we will get our answer. Probably the easiest equation to use is the one with the smallest number in front of all the variables, probably number 3. So if I'm taking number 3, I know my x, I'll just write it out, x plus 5y minus z equals negative 20. I know my x is negative 2. I don't know y, so that's what I'm going to solve for. And I know my z is 3, so minus 3 equals negative 20. Well, if I combine my minus 2 and minus 3, I get minus 5. 5y minus 5 equals negative 20. Add 5. And again, I need more room. We get 5y equals negative 15. Divide by 5. Y equals negative 3. Alright, so when we write out our answers, we usually write them out in alphabetical order, x, y, and z in parentheses, almost like a point, but it has three components to that point. Usually it's just x, y for a point, but now it has x, y, and z. So it would be negative 2, negative 3, and z is positive 3. So there's my answer. Let's go to the next problem on the next page. So example 2, we're going to solve the system. Again, I'm going to label them as 1, 2, and 3. And I can see, let's see, which 2 do I want to work with? None of them will just automatically cancel something out. So I can multiply, let's see, if I multiply the bottom, the number 3 by a 2, it would put a 2 in front of this b here, a negative 2 because this is already negative, and I can add it to this plus 2b, and I'd eliminate a b. So I'm going to take equation 2, and I'm going to take, and this is how I'm going to write this. I'm going to take 2 times equation 3. Okay, so I'm going to write it like that. So I know this thing was this, whatever I put in for this equation 3 spot, it's going to be doubled. So equation 2 is going to stay the same. It's a plus 2b minus 3c equals 25. And I'm taking 2, well, let me write my 3c right here. Get rid of these things. C. All right, and I'm taking 2 times equation 3, so that's going to be 8a. 8a minus 2b plus 2c equals 50. I'm going to take those two and I'm going to add them together and I'll eliminate my b. So I'll have 9a, my b's will cancel out, and I will have a minus c equals 75. All right, we're going to use this equation later, so I'm going to label, instead of labeling it 1, 2, or 3, I'm going to label it, I don't know, star or asterisk, whatever you want to call it. Equation star. Okay, now we're going to want to use either equation 1, we're going to have to use equation 1 because we used 2 and 3 the first time. Now we got to use equation 1 with one of these other two to eliminate a b again. And we can see I got a negative 3b and a plus 2b. In order to do that, I'm going to have to multiply both equations. I'm going to have to multiply equation 1 by 2 and equation 2 by 3, and it's going to make a plus or minus 6 for my b's. So let's do that. We're going to take 2 times equation 1, so I'll write that as 2, oops, put the parentheses around the 2, times, and then we'll call this equation 1. And I'm going to do 3 times equation 2. We'll put a little dot there, I guess, but you don't have to. So 2 times equation 1 would make 6a minus 6b plus 8c equals negative, what do we got? Negative 46. Sorry, lost train of thought there. 6a. All right, so when we do 3 times equation 2, we're going to get 3a and then plus 6b and minus 9c equals 75 again. 3 times 25 is 75. And we're going to add these two up. When we add them up, we're going to get 9a. The 6b and negative 6b are going to cancel out. And I'm going to get a minus c equals 75 and 46 is, shoot, grab my calculator. 75 minus 46 is 29. All right. So I'm looking at 9a. I'm going to call this triangle. That's equation triangle. So I'm going to take star and triangle, and I'm going to see what variable I can eliminate. So if I have star, and I can see, well, let me look at these before I start writing things down. I got a 9a minus c and a 9a minus c. I can either eliminate the a's or the c, but I'm going to have to do it by multiplying 1 by negative 1. So let's say we're going to take the triangle, or the star one, sorry, and multiply it by negative 1. So that would make negative 9a plus c equals negative 75. And then I'll take triangle, the equation triangle, and it'll be 9a minus c equals 29. When I add them up, you see that these cancel, those cancel, and when everything cancels in addition and subtraction, you get a 0. And negative 75 plus 29 is negative 46. And 0 does not equal negative 46. That's not true, so this is a no solution one. Let's look at example 3. We have, and again, I'm going to label these 1, 2, and 3, just to keep them organized. If I'm looking at equation 2, I don't have a z. The z's already eliminated in equation 2. So my best bet is to take equation 1 and equation 3 and eliminate one of the z, or eliminate the z's in those two equations. And to do it, I'm going to have in equation 3, I'm going to have to make this z a positive 2z. So then when I add to the negative 2z, it will eliminate. So I'm going to have to take equation 1, which is x minus y minus 2z equals negative 6. And I'm going to have to take negative 2 times equation 3. And that would give us negative 8x positive 8x, sorry. So 8x, and it would give us negative 2y, and negative 2 times negative z be plus 2z equals negative 24. And when you add those together, you're going to get 9x minus 3y. The z's cancel out, positive negative 2 z's, and we get negative 30. All right, so I have that. We're going to call that one star. Oops, terrible star. Call that star. And we're going to look at star in equation 2. Now I have two equations with just x and y in it. In order to get them to cancel out, I need to take, and I can either take, and let me get my pointer here. I can take this 9x and the 3x, I can multiply this one by negative 3 to make a negative 9x, and they would cancel out the x's, or I can multiply both equations by this one by 3, this one by 2 to make a plus or minus 6y. I think it's easier just to multiply one of them by one equation than 2. So I'm going to take equation 2 and I'm going to multiply it by negative 3. So negative 3 times equation 2. And that's going to give me negative 9x minus 6y equals positive 75. And I'm going to use star now because I don't have to multiply by anything because I got a positive 9x and they'll cancel. Minus 3y equals negative 30. And when I add them together, the negative 9x, positive 9x cancel out. I'm going to get minus 9y. Oops, let me put that in black. Minus 9y equals 45. And I divide by negative 9. I don't know why my 9s won't make. They just won't work. Divide by negative 9, y equals negative 5. Okay, so I have y equals negative 5 now. I can use one of my two equations, either 2 or star, to find x. So if I just plug it into equation 2, so equation 2, and I'm going to take 3x plus 2y equals negative 25, and I know that y is negative 5, so 3x plus 2 times negative 5 equals negative 25. If I do that, then I get 3x minus 10 equals negative 25. Add 10. I get 3x equals negative 15. And if I move this a little bit, I'm going to divide by 3. X equals negative 5. So I've got x is negative 5. I've got y. This is a y. That's a terrible y. I got y is negative 5. X is negative 5. Now I got to use equation 1, 2, or 3 to figure out my z. Let's just go with equation 1. Equation 1 is x minus y minus 2z equals negative 6. I know my x is negative 5. Negative 5. I know my y is negative 5. So minus a negative 5 minus 2z equals negative 6. Well, now minus a negative is positive 5, so I got negative 5 plus 5 minus 2z equals negative 6, and those just cancel out, so I got negative 2z equals negative 6. Divide by negative 2, and z equals 3, so I got, for my answer, negative 5 for y, and 3 for z. And that's all for this section. I will see you in class.